In topic 1, we're going to be looking at developing a system of linear equations. So a system of linear equations is a set or collection of linear equations, aka two or more equations that you deal with all together at once. So for instance, here are two linear equations. You can see they are written in slope-intercept form, and since there are two of them, they're going to be working together in a system. So let's figure out how to come up with systems of equations given word problems. So in example 1, it says create a linear system to model this situation. The perimeter of the Nunavut flag is 16 feet. The length of the flag is 2 feet longer than its width. So we need to use this information to come up with a linear system, meaning two or more equations that create this system. So let's start off with talking about the perimeter of this flag. Perimeter? Now the perimeter of any object is going to be equal to adding up all of the sides together. So let's start off by just labeling all of these sides. I'm going to label this side the length and then this side the width. So if we were to calculate the perimeter from this, it would be length plus width plus length plus width, because that would give us the distance all around the flag. So now that we have perimeter is equal to length plus width plus length plus width, let's plug in some numbers here, because they did tell us that the perimeter is 16 feet. So therefore we would have 16 is equal to length plus width plus length plus width. And we can also clean this equation up a little bit because we have some like terms. We could combine the L's together and we could combine the W's together. So we are actually going to have 16 is equal to, well, if we have L plus L, that's the same as 2L, or 2 times the length, and then plus W plus W is the same as 2W. So that there is the equation for the perimeter of the flag. Now you'll notice in the next line of our question, it says the length of the flag is 2 feet longer than its width. So let's use that information to come up with our second equation. So if we have the length is 2 feet longer than the width, well, that would mean that the length is equal to the width plus 2. Therefore, our linear system is going to be 16 is equal to 2L plus 2W, and then the length, or L, is equal to W plus 2. So that there is our answer for this question. Now in part B, it says Denise has determined that the Nunavut flag is 5 feet long and 3 feet wide. Use this linear system from part A to verify that she is correct. So whenever you see the word verify, you know that you have to use that left-hand side, right-hand side system that we use to verify equations. So it says that she determined that the flag is 5 feet long, so our L is going to be equal to 5, and 3 feet wide, so our W is going to equal 3. So now let's do our left-hand side, right-hand side to see if it works. Now we're going to do that on both equations that we came up with. So left-hand side, right-hand side. So in this one, I'm going to do the first equation, the 16, and then on the right-hand side is 2L plus 2W. So then let's plug in our values here and see if we can get the left-hand side and right-hand side to equal each other. So we'd have 10 plus 6, which would be 16. So the left-hand side is equal to the right-hand side. So it does work for that equation. Let's see if it works for the other one. So now we have L on one side and W plus 2 on the other side. And if we plug in our values here, we will see that the left-hand side and right-hand side do equal each other. Therefore, we have verified that Denise is correct with these numbers that she gave us. Now, I do want to point out that when we're coming up with these linear systems, you want to always have two variables, because with all the linear equations we did, we had two variables. It was x and y in both of the equations. So for all of these linear systems we're coming up with for these word problems, they're always going to have two variables. That is why I chose the length and the width to be my two variables on this question here. And this is a very common question. You'll see a lot of them that are very similar to this that use the length and width of an object. Now let's look at example 2. Create a linear system to model this situation. In Calgary, a school raised $195 by collecting 3,000 items for recycling. The school received 5 cents for each pop can and 20 cents for each plastic bottle. So again, this is a very common question. So let's start off by defining what variables we're going to use. So we're going to use two of them. For this question, we should use a variable for pop cans and we should use one for bottles. So let's just define it here. We have cans and bottles. So I'm going to let C equal cans and I'm going to let B equal bottles. And it's very important that you write this down and define what variables equal what. Even though it's kind of obvious, you would be like, oh, of course C is can and B is bottle. But that is something you will lose marks for in pre-cal if you don't define it like we did right here. So make sure you put that step. So now that we defined our variables, we want to come up with our two equations. So let's start by looking at this first line here to come up with our first one. It says, in Calgary, a school raised $195 by collecting 3,000 items. Now we know that the items they were collecting are pop cans and plastic bottles. So total items is equal to 3,000. And the only items they were collecting are cans and bottles, but we don't know how many cans or how many bottles. So I'm just going to put C plus B is equal to 3,000. So that's saying if we add all the cans and bottles together, we should get 3,000 items. So this here is our first equation. Now let's look at the second. So for the second one, I would use this second sentence to kind of get some information from it. It says the school received 5 cents for each pop can and 20 cents for each plastic bottle. And in total, they raised $195. So now I'm kind of taking all of the information that has to do with money and putting it together in one equation. So I know that they raised $195. So if we got 5 cents for every pop can and 20 cents for every plastic bottle, that needs to equal $195. So I'm going to have 195 is equal to, and then 5 cents would look like this, 0.05. And we're going to times that by the C because we get 5 cents for every can that we collect. So if we collect one can, 1 times 5 cents would be 5 cents. If we get 2, then it would be 10 cents and so on. And then we're going to add that to the 20 cents, so 0.20 for every bottle that they collect. So this here would be your second equation. So then our final step would just be to state the linear system. So I'm going to say the linear system is C plus B is equal to 3,000 and 195 is equal to 0.05 times C plus 0.20 times B. So that there's our final answer. Now the school collected 2,700 pop cans and 300 plastic bottles. Use the linear system from part A to verify these numbers. So again, we have that lovely word verify. So we need to plug these numbers into that left-hand side, right-hand side table and see if both sides equal each other. So 2,700 pop cans, so our C is going to equal 2,700 and our B is going to equal 300. So then I'm going to have left-hand side, right-hand side, and this will be for our first equation. So we'll have C plus B and then 3,000 on the right side. And let's see if we plug in these numbers, and you can probably see right away that this will definitely equal each other. So we have 3,000 and 3,000. So left-hand side is equal to the right-hand side. And we'll put a nice little check mark because that is correct. And now let's do the other equation. So left-hand side, right-hand side. So now we have 195 on one side, and then we have 0.05 C plus 0.20 B. And we need to plug in these numbers. Now, I wouldn't give you numbers like this on a test necessarily. These are pretty big numbers to calculate in your head. So if you need to use a calculator for this one, that is a-okay. But if we were to plug this into a calculator, you will get 135 plus 60, which is 195. So again, the left-hand side is equal to the right-hand side, and we verified that this is correct.